Today we're going to go over the discriminant. And the discriminant, didn't mean to cross that out, is actually a section of the quadratic formula. Now, they show it sometimes in different ways in the book. Our discriminant here is going to be equal to b squared minus 4ac. Sometimes they'll show it with a root on top. It's not going to make a difference because we're going to still have the exact same rules whether you have a square root on top or you don't. The reason we focus on this part of an equation is the discriminant will tell us how many x-intercepts we have. So, let's say, for example, there are really about 3 different answers you can get for this. And we talked a little about this with the quadratic formula. You can have quadratics like this, which would have how many x-intercepts? That's right. These two would have 0 x-intercepts. And if this is the case, what you're going to find is the discriminant, okay, is less than 0. Now, when I say less than 0, what does that mean the discriminant is going to be? Negative number. Any negative number, okay? And in that case, we're going to have 0 intercepts, okay? And specifically, sorry, x-intercepts, not y. Another option we could have is when we have our quadratics that are just touching the x-intercept, okay? Something like this or something like this. How many x-intercepts would this have?
1.
Yes, exactly. So this is 1 x-intercept. Does anyone know what the discriminant will equal when we have 1 x-intercept?
0.
Yes. So in this case, your discriminant is specifically equal to 0. So in order to have 1, you can only have 1 answer for the discriminant. It has to be 0. Okay? Can't be any other number in this case. So here's case 1, case 2, and finally we'll do case 3 here. This is when the discriminant is larger than 0, b squared minus 4ac. Okay? And in this example, how many x-intercepts do you think we're going to have? 2, exactly. Maybe we have something like this, or crosses the x-axis twice, or something like this. Okay? Can I have any other options? Can I have more? Can I have more than 2? No. Can I have less than 0? No. So these are your only 3 cases with quadratics when you're graphing them. You either have 2 x-intercepts, you have 1 x-intercept, or you have no x-intercepts. Now, the reason we use just this part of the formula is because what we're going to find, let's talk about this. If we have something where the discriminant is less than 0, in other words, negative, this is specifically this part of the quadratic formula. So if I have a negative value under the root, something like negative 15, can I square root that? No. In other words, I cannot continue to go any farther. Therefore, I have no x-intercepts in this case. If, in our second case, we have it equal to 0, I find the square root of 0. What is the square root of 0? 0. So what I'm going to have is plus or minus 0. Is that going to make a difference whether I add or subtract the 0? No, so I'm still really just going to have 1 answer in that case. You could still split your quadratic formula, but both answers will be identical in that case. And then finally, we have a value where the discriminant is greater than 0. Let's say, for example, the root of 9. Well, then we're going to get plus 3 and minus 3. And that's going to give us 2 very different answers. Okay? So that's the reason we just focus on this. So if we get a question and they're asking us how many x-intercepts something have, we don't actually have to go through the entire quadratic process. We can just use this part of the quadratic formula, which we call the discriminant, to figure out how many x-intercepts there are. So we know relating to standard form when we're talking about the quadratic formula. So if a is 2, our b is negative 5, and our c is 3. So let's go down and solve this specific one. Our discriminant, I'll even call it d, is equal to b squared minus 4ac. Our a in this case was the value of 2. B was negative 5. And c, I believe, was 3. We'll double check those numbers one more time. 2, negative 5, 3? Yes, that's right. So we're going to plug those values in. We're going to get negative 5 squared minus 4 times 2 times 3. Okay. What is negative 5 squared going to be? 25. Okay. Now, when you're multiplying this, think of this like it is maybe negative 4. So we're going negative 4 times 2 is negative 8 times 3, negative 24. So what is our discriminant value going to be? 1. So how many x-intercepts will we have?
2.
We're going to have 2 x-intercepts, or roots sometimes they call it. Yeah.
Couldn't you also find out whether it has 2 or none by if it can be factored?
No, because the way we have been taught the factor, sometimes we can't factor something, but we can put it into the quadratic formula. Okay? And the quadratic formula sometimes gives us decimals. Say we get answers like 2.69, 7.3 as your roots. We'll use a quadratic formula. Now, technically you could factor, but that's very complex for us. So if it's not easy for us to factor, we step into doing the quadratic formula.
But if it can be factored, then you can safely assume there are 2 x-intercepts.
Yeah. Or 1. Or 1. Okay? If you can't factor it at all, then you can say there's no x-intercept. Okay? Let's say, and there's 2 other options. So we're going to quickly do the 2 other options here. Let's say we get value of 6. So our b will be negative 6. 6x. Our c will be 3, and our a will be 3. So 2x squared. Okay. So here's our standard form of 1. Okay, so we have a standard form. We want to figure out how many x-intercepts this has. We're going to plug it into the discriminant, which is b squared minus 4ac. b in this case is negative 6, so negative 6 squared minus 4 times 2. Oops, sorry, I didn't mean 2. I needed that to be 3 for this to be a different case. Okay? So times 3, our a value is 3, and our c value is 3. Okay? 6 squared will give us, yeah. And then negative 4 times 3 will give us negative 12 times 3. 36. What are we going to get? How many x-intercepts are roots? 1 root, I'll call it this time. A root is the same as an x-intercept. Okay. And finally, let's make one last one. F at x is equal to negative 10 x squared plus x minus 8. Okay? So let's plug this one in. And instead of writing this discriminant out, I'm just going to go straight to it. What's our b value here? 1. So we're going to have 1 squared minus 4 times, what's our a? Negative 10. And what's our c? Negative 8. Okay. What's 1 squared going to be? 1. And then we multiply all these together, we're going to get, anyone know? Anyone know specifically?
Well, 4 times 10 equals 40.
Yeah? Good.
40 times 8.
Good. So we'll have negative 319, which means how many roots will we have? 0 roots. If it's a negative value, no matter how big or small, we'll have no roots, okay? And that's essentially how we use the discriminant. Essentially decide how many roots a question has. Celeste.